Hello, welcome to a new lecture on body plot and the terms associated with it. So, if all of you are new to this channel, you can subscribe and watch the previous videos to get these concepts. So, today in this lecture, I will be discussing the critical topic of the gain margin and the phase margin. Before going to the gain margin and the phase margin, we will understand certain important terms. These terms are as see, these terms are the gain crossover frequency. So, what do you mean by gain crossover frequency? So when I'm talking about this gain crossover frequency, this frequency basically represents the magnitude of Gj omega and Hj omega. So it represents the magnitude of of Gj omega Hj. What is the Gj omega and Hj omega? It is the open loop transfer function. It is nothing but wherein we used to get in the time response analysis, open loop transfer function was represented as Gs and Hs. So only the value of S is replaced by G omega. So when I'm talking about the gain crossover frequency, so I say that the frequency at which the magnitude of open loop transfer function, that is Gg omega Hg omega is unity is equal to 1 is called gain crossover frequency. Okay, so this is basically the gain crossover over frequency. So in mathematically, this term can be expressed like, see, we express all the terms in dB. So 20 log natural log to the base 10, 1 is equal to 0 dB. Okay, so if you have to express this in dB, so we can say the frequency at which magnitude of Gj omega Hj omega is 0 dB is gain crossover frequency. So when the magnitude, okay, becomes 0 dB, okay, it happens at gain crossover frequency, which is represented by omega gc. And the second term, which is very important, is the term called as the phase crossover frequency. Phase crossover phase crossover frequency. So what do you mean by phase crossover frequency? This is represented by omega dc. So we can say that the frequency at which the phase angle of the Gj omega Hg omega is minus 180 degrees. Okay, so wherein the phase angle of G omega Hg omega, that is the open loop transfer function, is minus 180 degrees, is called the phase crossover, is called the crossover frequency phase crossover frequency. So this is also very important with respect to the examinations. Any exam will be asked. So what do you mean by gain margin? Now comes the important term gain margin. So just like how you are varying the value of K, okay, in your plant. So how you are varying the value of K in the plant wherein you had this input as R of S, and this was your feedback, and this was your output C of S, and this was your P. So you are varying this K, and this variation of the K from 0 to infinity was determining whether your response would be, whether your system would be stable or unstable. Okay, so here stable or unstable. For here also, we have a term in the frequency domain analysis which is called as the phase margin. So here in the phase margin, if you look, sorry, the gain margin, first term is the gain, then we'll discuss the phase margin. So as seen in the root locus, we saw the variation of the gain as I've already discussed it beforehand. Stability would reduce for a certain value of k and it would become margin stable. Now, gain margin basically is defined as the margin in gain allowable by which the gain can be increased when the system reaches the verge of unstability or till the system reaches the verge of instability or up to the marginal stability. So this is how the gain margin is defined. So I'll write down the gain margin. The gain margin is defined as the margin as the margin in gain allowable by which gain can be increased, okay, till system reaches verge of instability. There is no place instability. Okay. So when I'm discussing this point, so I'll say that what is the positive gain margin and the negative gain margin. Now so yeah, hold on. So when I'm talking about this gain margin term here, yeah. So this positive gain margin would mean that for positive gain margin, K is possible. Okay, K is possible before system becomes unstable. So what does it mean? The system is stable for positive gain margin. Okay, and the system is for the negative gain margin. K is okay. System K is stable. K is stable, and this system K becomes unstable. Okay, unstable. So I will explain you. Uh, the positive gain margin would mean that an increase in K is possible before the system becomes unstable. Whereas in case of a negative gain margin means K is already greater than the K marginal. K is already greater than the K marginal. So hence you can say that the negative gain margin would mean the system is unstable. So if you want to discuss this as mathematically, it can be defined as the reciprocal of the magnitude of Gj omega Hg omega measured at phase crossover frequency. So the mathematical definition of this gain margin is okay, it is the reciprocal of the magnitude of Gj omega Hg omega measured at the corner frequency, measured at the phase crossover frequency which we just decide omega PC. So what is the phase crossover frequency? It is that frequency at which the phase angle is minus 180 degree. Okay. So this is meant, and this same gain margin in decibels we represent it as 20 log of 1 by Gj omega Hj omega omega is equal to omega PC. Okay. So if we want to express this, because this term is in reciprocal term, if we want to express this, see 1 by j would be represented 1 by log 1 by a. If I have to write, so I can write as this as log a inverse, which can be written as minus log a. So this is the elementary. So here also it can be directly, if this whole part I take as 1 by a, if this part is a, then I can also write it as minus 20 log of 20 log you have to see to be careful. Log to the base 10 you have to take minus 20 log to the base 10 g j omega at j omega, and it will happen at a phase crossover frequency. So this is basically more for if the gain margin is positive, okay, more positive, then system is more stable. So this is more stable. Now comes to the term of phase margin. Now, what do you mean by this phase margin? Similar to the gain margin, it is possible to introduce a phase lag in the system. Okay, that is the negative angles without affecting the magnitude plot of Gg omega and Fg omega. So, like, uh, it is possible to introduce a phase lag in phase lag in system, system. Phase lag would be introduced with help of negative angles, okay, without affecting what, without affecting magnitude of gj omega and hj omega. So this is basically the definition. Mathematically, this thing, if you want to express this mathematically, so we can express this mathematically as, yeah, so this term can be mathematically expressed as See here, phase margin, if like the gain margin, we can express this as angle GJ omega HJ omega, okay, and this has to be at gain crossover frequency. Omega is equal to omega GC. Uh, this angle minus of minus 180 degree would be the mathematical. In other terms, the phase margin is equal to minus and minus at 180 degree plus the angle you have obtained of GJ omega HJ omega, and this has to be omega is equal to omega GC. So this omega is equal to omega GC is basically the gain crossover frequency, which we have told already. So what is the gain crossover frequency? It is the frequency at which the magnitude of Gj omega Hj omega is equal to 1. So when it is possible, when in the decibel scale, when you see write 20 log 1 is 0. So 20 log of 1 is equal to 0 dB. So that is the value possible. So we will stop this lecture here. After this lecture, I'm going to make a problem on gain margin and phase margin. It's a very important problem. After that, we will be understanding the Bode plot and how to construct it. So please follow the lecture. And if you are new to the channel, please subscribe to the channel to get more information. Thank you. Thanks a lot.